understand 3D Mohr circle or Mohr circle better than anything else. Right, so today we're going to look at this example. So this problem wants us to find what is the value of stress Y. And I'm going to show you 4 possibilities. Okay. And more important is why certain answers are correct and certain answers are wrong. Okay. So as you can see, you have this image. I'm going to label this as our, like before, this is our point X, point Y, and point Z. Okay. And what is given to us is we know that point X or stress X is at minus 50 MPa. We are aware that stress Z is equal to 0. And we know that shear XY is equal to shear YX. And this is equal to 48 megapascal. Okay. By the way, this is the second most complex question in Mohr circle. Okay. After this example, I'll show you another one which is the worst. And so this is not the worst yet. So we are going to find, given to us, the stress max either in plane or the stress max out of plane is equal to 73 megapascal. So the circle diameter cannot be more than 73 megapascal, but we don't, some situation is in plane, some situation is out of plane, okay? So for this case, this is also known as the radius of our circle. Okay, I want to put down here sometime, or most of the time, or most of the time, okay? Now, we also know that stress max and mean, okay, can be equal to 73 times 2. Okay. 73 times 2 is equal to 146 plus or minus 146 megapascal. Okay. Now, why is that? Why is it 146? Okay. How did this happen? Okay. So I'm going to do a sketch. Okay. So this is just a sketch. Okay. So this is normal stress, shearing stress, element rotate clockwise, and element rotate anti-clockwise. And I'm going to sketch, okay, as you can see, I think the resolution of the display is good enough. I'm going to sketch 5 square above, a red line, and this is going to be my tau max. And the bottom red line okay, this is also my tau max. Or I put it negative down here. Okay, let me, yeah, I think we have, maybe we have not enough space. Maybe I need to go further. Okay. And we know this is equal to 0. At the center, 0 normal stress, 0 shearing stress. Do apologize. I'm messing around down here. My bad. Let me draw the red line again. 2, 4, 5. Okay, then let me draw it again. So this is still our tau max line. Okay. Now, as you can see, the distance from here to here is our radius. I know. It's our radius. Okay. So one thing we are very sure is at the center over here, this is our point Z. Because point Z is at a point that the normal stress and shearing stress is equal to 0. Okay. So the next thing I'm going to draw the circle that touches the maximum positive shear and the maximum negative shear. Okay, so this is the circle. Okay. So we know one point, okay, at one point, it has to touch the Z at the minimum point. So stress max or stress minimum is at 0 point. Okay. So when that's the case, I can draw now, sketch a perpendicular line. I'll use a different color that's coming down from the top. And this happened to be what? The distance from here to here happened to be equal to what? R. Okay. So this is your stress max. Okay. So stress max is equal to what? 2R over here. All right. It has to touch, Z has to be equal to what? 0, because that point we are very sure. Okay. Now some of you might ask me, Eugene, then where's point X and point Y? Point X and point Y can be within the circle, or it can be part of this big circle. Okay. Now then, if I move to the next side, okay, this is the next possibility. Okay. And then if I'm going to draw a blue vertical line coming down, and we know the distance from here to here is also equal to 2R. So we know that our stress mean is also equal to minus what? Wow. Okay. Right. So if radius is equal to what? 76. Is it 76 for this problem? 73, sorry. The maximum will be positive 146. The minimum will be minus what? 146. Okay. Now, anything that I shade in red, the circle cannot go outside. Okay. So your Mohr circle, the 3D Mohr circle, must be within the shaded boundary. Okay. it must be within the shaded boundary. It cannot go outside. Part of it cannot go outside. If your circle happen to just be like this, okay, if your circle satisfy, okay, the shear, right, and it goes outside, the structure will fail. Okay, fail or not meet design requirement. This is before buckling, okay? After buckling is another paradigm. Are we clear? Okay, so if the circle happen to go outside, the stress makes the structure will what? Will fail. Or another situation, it can be within the structure or within the box. Let me change this into a different color so you can see better. Let me change this to pink, okay? No difference, Eugene. Really? Change this to orange, okay? What if now, right, your circle looks like this? Okay, so now your circle, it is within the what? It is within the limits of your normal stress, right? It's within the limits of the normal stress. For this case, the shear is greater than your tau max. Can you see that? When this is the case, okay, failure will occur or fail to meet design requirements. Okay. So it must be within the confined boundary. Okay, confined shaded boundary. Okay. So this is where we just combine what? This is where we combine stress yield to what? Mohr circle. Because this, most of the time, all these are your stress yield. Okay, most of the time, this is your minus stress what? Yield. Okay, are we clear? Okay, so this is where you see Mohr circle combined with stress strain curve. They are all related. Are we clear? I know it looks a bit much, but it's not complicated once you get used to it. Are we clear? Okay, right. Now we understand this now. We are now going to do the question now. Okay, we are going to attempt this question. Okay, I always put things up. It's okay. I don't want to waste your time. This is my slide number 1. It's not you, okay, it's me. And we go slide number 2. Okay, so now let's look at this problem now. We start constructing Mohr circle. Okay. But before we go here, last week, I showed you the solution. Okay. Very interesting. But you no need to use this way to find your answer. Are you clear? Are we clear? I'm going to use Mohr circle, and all you need to do is just to combine the operating boundary of where the circle must be within, okay, and 2D Mohr circle and also 3D, okay, and it's really, really what? Straightforward. It's not difficult at all, okay. Right. So now I'm going to sketch Mohr circle. Okay, I deliberately make it so big Okay, deliberately. Okay, it does not need to be so big, but I will draw it big. Okay, so we have 76. Okay, so 0, 20, 40, 60, 80, 100. In shear, element rotate clockwise, minus 20, minus 40, minus 60, minus 80, minus 100. Rotate anti-clockwise, 20, 40, 60, 80, 100, 120, 140, 160, 180, normal stress, minus 20, minus 40, minus 60, minus 80, minus 100, 120, sorry, 120, 140, 160, 180. Okay. And then we are going to sketch our box. Okay. So the box is 73 in terms of shear. So I'm going to sketch the green line in red, 73. Okay. So I'm going to eyeball this. And this is my 73. Okay. So 73 is about here. And then I'm going to do the next one. 73. About here. And then next, we're going to draw the vertical 146. Okay, so this is 146. And on the other side, it's going to be our 146.